Well, hello, everybody. Thanks. I hope everybody had a good lunch and we've had some great talks this morning. And so we're going to talk about APRS. In an hour, I'm not going to be able to talk about all of it, but certainly talk about a lot of it. And then if you guys got questions anytime on a particular subject, you want a question about it. If I don't cover it, I'll answer it right there. And if I do cover it, I'll say, wait for the next whatever slide. All right, let's get going. All right, so what is APRS? Okay, so it's an abbreviation for Automatic Packet Reporting System. It uses a packet communications protocol for disseminating live data to everyone that's on a network in real time. It gives tactical situational awareness of everything on the net, which is really important if you're doing like an APRS event or something like that. You need real time, like for a bicycle event, something, some kind of not a race, but an event. It's also fully integrated with the internet. Depending, I mean, you might not want it part of the internet. You might have a private network going, but usually there'll be an iGate. Talk about that, where the information is received and it's put out onto a server for people to look at through a browser. And also, this is the part a lot of guys don't know about, and you're going to find out about it. So you can send email and text messages. You can actually have conversations back and forth using APRS. So packet itself, packet radio goes back to the late 70s. It was first researched on the amateur bands in Montreal, Canada. And the first TNC was developed in 1982 by TAPR, the Tucson APRS group. From there was an outgrowth of BBS and packet networks in the 1990s. Bill Rinker at W6OAD is really a big expert on that. He used to give lectures on that back in the 90s, and he's still an expert in it. And then, so nowadays, APRS, National Traffic System, and a lot of emergency operations centers are using the packet to deliver messages, usually with WinLink, but could be with others. So the history of APRS then was, once packet was developed, it was first used in the mid-1980s, and it was integrated with amateur radio, GPS, and maps. And global positioning started becoming more used as the receivers became less expensive and also more accurate. As a side note, I remember GPS in the late 70s. I was on a C-130, a Navy C-130, and we used to fly all over Antarctica, and I collected 24,000 nautical miles of what we call today GPR, ground penetrating radar data. We called it radio echo sounding at the time. And I got to map a lot of features in the ice, including we flew over the one, there's a lake that's melted underneath the ice, and you get a really good reflection from water with radar. APRS is a registered trademark of the late Bob Reninga WB4 APR. So the X.25 protocol was developed in computer circles, and mainly with X modem to start with. So it was a way for, when you connected to a computer system or BBS or something like that, you could upload and download data, files and things using this X.25 protocol. And the advantage of it was that it would do the full 255 bits or 255 character set. It would move it in an 8-bit manner. And so then that was modified for the amateur radio use. And so we call it AX.25 protocol. And it's like the internet protocol, basically. So in APRS, we're going to send location data, date and time. Location data is usually in Latin long. You can put other telemetry data in there. For instance, Mark over there said that he wanted to send voltages, and you can do that. And I know some other people in areas that want to send voltages to know if the repeater needs to have the batteries replaced. And of course, elevation, if you're doing balloons, you're going to want elevation. Where am I at? or how high am I, guess. Make sure one of our F-16s doesn't shoot it down. It's a one-to-many protocol. So when you transmit, it goes out and anybody can listen and hear it all at the same time. We have what's called digipeating. Now, digipeating exists in regular packet radio. It also exists in APRS. And the purpose of the digipeating is that maybe you're in a position where you can't get out to where you want it to go to. You might have to tell it, we're going to repeat this thing several times until it finally gets to where it's going. We'll talk a little bit about that in a bit. It also supports two-way messaging, which I've already hinted at. And then you can do email with it. You can do text to cell phones. I'll get to that some more. I don't have anything to do with demo here. So what is an AX.25 packet? Well, it's like an internet packet, basically. The packet has a frame and it has a bunch of data in the frame. It's got a destination address and a source address. Now, if it's internet, we're going to have an IP address, where it came from, where it's going. If it's a call sign, we're going to have a call sign of where it came from and a call sign of where it's going to. And we have a repeat counter. So how many times it can be repeated by several stations. The number of bytes in the frame, that's important because you want to know if you got the whole frame or not, whether it's messed up. It's also has a sequence number. You might have data you're sending and it's more than one packet of data. So we're going to have a sequence number in there to know this is like 1 of 25, 2 of 25, 5 of 25. Oh, what happened to 3 and 4? Hey, resend me 3 and 4, please. And there's an error checksum. So there'll be, each frame will have an error checksum, and both the sender and the transmitter, the receiver, will then check the checksum and see if it compares to what the other guy said. And if it doesn't, then there's a problem.
Larry?
Yes.
Did you say you ask questions now?
Yes, go ahead.
Destination address. What do you do in the case like when you're flying a balloon and you don't have a specific address? You're just broadcasting where you are.
That's a good question. And I was just thinking about that after I said that. And I'm not sure. I'll have to look that one up. That's a good question because I guess for packet that makes sense, but for APRS, I don't think it matters because it's just going out. You want eventually for it to go to the iGate. So real quick, this is the packet address field. And so in there, you'll see that there's a destination and a source. Those are 8 bits that are in there. And in our case, we'll put a call sign in there. And there's also a place for how many times it's repeated in that header. And there's also an SSID in there as well. So you can see there's an SSID for both. But that's if you're going to write these things. If you're not writing it, it's all done for you with the software already. All right, baud rates. Now, this could change over time since we're talking about increasing the baud rates. Yes, you can see talking about that. So on HF, it's 300 right now, and VHF, it's 1200. When we get to the frequencies, I'll give you the frequency for HF that you can. There's actually more than one being used, but there's one main one on 30 meters. So hardware. So this is old school hardware back in the old days for this thing. So you'd have a GPS puck of some sort. You got a computer it's hooked to. You'll have, or it might be hooked to the TNC. And you'll have a serial cable, the TNC radio cable that goes from the TNC to the radio and the radio. So this whole setup. So the computer would have some software running, and it's going to generate an APRS packet with the information in it, sends it out to TNC, and then sends it to the radio, and it goes out. So if we go to a sound card interface, which is now another, I guess the next step up was sound card interface, which looks kind of complicated because of all the connections that got involved here. But basically, there's no TNC involved. The computer has enough processing power that you don't need the TNC anymore. So it's going to use a sound card on the computer to generate the necessary tones, send the data out, and to receive it. This one I really like with a Tigertronic signal link. So it's really easy because you got one cable from the computer, one cable to the radio. It's very simple, easy to do in a car or at a home station, whatever. So GPS receivers, you can buy them anywhere. They're in tablets, they're in smartphones, they're in amateur radios, and they're in navigation devices. All you got to be able to do, though, is be able to get the information, which is usually an MEA output. You got to get that into your data stream somehow, usually through a computer or some other device. And they're not very expensive anymore either. Thank you. So some TNCs, terminal node controllers, Cantronics 3 Plus, even has specific information in the manual of how to hook up a GPS to the unit. Of course, for GPS, you can use all these other devices. Some of these are older. The TNC Pi, the guy that had that sold it to MFJ, and MFJ is starting to produce them again. TNC Black, I don't know whatever happened to that one, because it's by the same guy. And of course, radios with built-in TNCs are very popular now. And the little tiny Bionics, tiny tracker, you can use something like that too. And we'll kind of browse through some of this equipment. So here's an MFJ TNCX, pretty simple to use, but you can use that with the GPS in your computer to send out APRS data. We got the time wave, can be used. And of course, Cantronics, which is about this big, not very big, maybe 3 inches by 3 inches. The new ones are nice because they have USB connectors on them to your computer. Raspberry Pi and a TNC Pi. So the Raspberry Pi itself, a lot of you have them already. Oh, by the way, the new 5's coming out, should be at Micro Center soon. It's same as the 4, just a little faster, maybe 50%, 30 to 50% faster. Anyway, the Pi, TNC Pi, just goes right on top of the Raspberry Pi. And you can also get a display to go on top of that. And so you can have it running Zaster on the Raspberry Pi. You can actually have a touch screen to do things with it and actually interactively watch what's going on in the APRS world. Of course, this is my favorite for now, though I don't know if we can get them anymore, is the Kenwood TM710, both the A and the G. The A is the older model. The G's got the built-in GPS in the head, whereas the A, you had to have some other method of attaching some sort of a GPS to it. Kenwood also makes a handheld. They have the THD74A, and of course the 75 is coming out soon. And that, I'm looking forward to that. I definitely want to buy one of the Kenwood 75s when it finally comes out. And then Yaesu's FTM 500 DR does it, and I think the 400 does it, and I think the 300 does. Do you know, Rob, if the 300 does it? I can't remember. Yeah. So, but definitely the 400 and 500 do APRS. There's a little. Sorry.
Is the FT5 do it?
The FTM5. Oh, the 5, the handheld.
Yeah.
There is a handheld that does APRS from Yaesu. I don't know which model it is. It is the 5. Okay.
Yeah. Okay.
And of course, tiny tracker again, really small. And you can see on the slide it says GPS/computer and radio/power. The only thing is, you have the GPS of it. I guess. Well, I'll send it out. You wouldn't be having any monitor or control over it. Yes.
So what kind of protocol do these devices use to keep from stepping on one another when they're transmitting to?
Before they'll transmit, they listen, and when the channel's clear, they'll send out. And they'll beacon. They have a lot of them have what's called smart beaconing. And it depends how you set it up. You can set it to have it do it over time, or you can have it set up over change in direction, or you can have it set up to do it based on some kind of changes in velocity, things like that. So you have a number of different ways. Smart beaconing kind of does all of it. And if I had just a home station and I'm not going anywhere and I'm being an iGate or a digipeater, then I would do it like every 30 minutes maybe and send out my address, just to let people know I'm there.
And if the FCC approves the APRS, which is going on, do they have plans to increase the baud rate? Because as I understand, this runs at something like 1,200 baud using an ancient modem protocol.
Right, and so I don't know what's going to happen with that because it's just doing a standard. It's basically a digitized voice going over an analog signal. That's what it is.
Yeah, it was like one of those old telephone modems where you put the handset in the
Right.
cradle.
Yep. I've never had one of those myself. I always had the direct connect. All right, so sound card interfaces. Of course, Tigertronics is a sound card built itself, but all these are some examples. If you go that route, I think the Tigertronics is probably the easiest way to go. For software, I know Mark was talking about this earlier when I was talking to him about his station out at Strasbourg area. Direwolf is really designed for APRS. It's a really good one to use. And I believe it runs on Windows and Linux. Not sure about the Mac. And then sound modem from UZ7HO is pretty cool. I've had some email exchanges with him. He does answer his email when he has the time. AGWPE Pro, he's from Greece, and you have to pay for the Pro version. And the Pro version allows you to use it unlimitedly. That's sound modem software, so that's so you wouldn't have to have a TLC. This slide's kind of fuzzy, but it shows the different frequencies in different areas of the world for APRS. Most of Europe, Russia, and Africa is 144.80, so you're going to use APRS on a card drive out there to make sure you get set up correctly. For us, it's 144.390, and if you want to know the HF one on 30 meters, it's 10.151 megahertz on lower sideband. It uses 200 hertz FSK. And if you're setting the DigiPeak on it, use Y1-1. The reason for that is if you beacon on HF, just about anybody's going to pick it up and be able to iGate it back to your internet. So you don't need any DigiPeak. And they're 30 meters is because it's on all the time. All right, so digipeaters. So a digipeater basically listens. It hears a packet come in, an APRS packet, and it looks at the header to see if it's supposed to be repeated or not, because it's decremented a number of times. And it looks to see if it's supposed to be repeated. If it is, it re-beacons it. If it's an iGate, it hears it. Doesn't matter. It doesn't care how many times it's been repeated. An iGate hears it, and then it's going to send it to the internet, to the servers. And sometimes more than one will get it, and they'll both give you acknowledgement. I get an acknowledgement on my radio when an iGate picks up my mobile station, and it will send it and give me acknowledgement that it sent it off to the server. Now, to be able to use the server as an iGate, you have to have a passcode. And APRS ISCE/32 website is where you can apply for passcode. You only need a technician license. That's all you need to be able to get a passcode. Yes.
So for a home station, could it be set up with just the computer and the software and no radio?
You wouldn't be able to collect anything.
Look at it from the internet. with the ID?
If you just had your home station and you sent out a packet over the internet, is what you're saying? Yeah, I guess you could.
This diagram?
If you have a passcode, yeah, you could do that. But no one else is going to hear you. It's just going to show up on, it'll show up on the APRS map, but no one can connect to you or anything like that. In theory, they could send you a text message or something via the internet. So here's how an APRS network works. Example of one, I guess. So you got all these vehicles and stations here. The digipeaters are the stars. The eye gate is a big G. Looks like a Masonic symbol. And then you got somebody, and you have all these different characters that are being used to represent the stations. Now I'll talk about a little bit about that in a little bit. And so anyway, you can see that people are basically beaconing, and some vehicles are picking it up, and some are digipeating them, etc. In fact, a mobile station can be a digipeater. And I've done that before for APRS events where we're up in the mountains, and some people have little handhelds, and they want to get their position out, and I can pick it up because I'm close enough to them that I can, but they don't have enough power to get anyplace else. And then I digipede it out on the planes, and then the plane sends it to an eye gate, and on the eye gate, then the people who are down in Golden at the event in the communications van, they look on their screen and they see where these people are. And then now you're into a global network. You see internet connectivity. So now we have all these different people. We have handhelds, we got eye gates, we got vehicles, and we have satellites. There are APRS satellites as well. And so now you can be just about anywhere in the world, especially if you have a Starlink connection. Then you can just about be anywhere, be able to get your message someplace. You might not have cell service, but you might have APRS service. Here's some of the software that you can use for APRS. UIView's been around for a long time. I don't even know if it's still around, actually. When APRS is out there, the other one I just mentioned was APRS ISCE/32 German outfit. It's free, and I use that most of the time when I'm doing a iGate or a base station or something. Pinpoint APRS was developed by Aries Deck in Douglas and County, and it's written by a Coloradan. And a lot of Aries people use that software for APRS events. Zaster, that's available for Linux. It runs on the Raspberry Pi. I've used it. Yak is yet another APRS client. That's another one that runs in Linux. APRS Droid works on phone. If you have an Android or an Android tablet. Someone told me, but I haven't been able to verify it, that it also works on iPhone now. Moved it over, ported it over. I cannot verify this. And either way, if you're going to be talking to a server, you have to get an APRS, you got to get a passcode. And if you go to the APRS ISCE website, there's an APRSISCE.wiki.com, and there you can go and apply for get a passcode. And all they do is it takes about 24 hours. They just want to verify your call sign. So here's my setup in my car. I have a AvNav, which is a navigation device. AvNav is an Italian company. They do aviation. That's where the Av comes from. They do aviation stuff. They do farming stuff. You cannot get an AvNav anymore in the US for amateur radio purposes. And they won't sell you one from Europe either. If you already have one, they will repair it. They will do support for it. I've had to contact them a couple times to get some maps updated and things. Below that, you see a Kenwood TMD 710. And what I like about this situation, there's a cable between my radio and the AdMap. And when I receive a station, it goes, the AdMap receives that data and makes a waypoint. So I can actually see that station. And if I need to go meet that station, I can actually say, navigate me to this station. And it'll navigate me through instructions to be able to drive to it or intercept it. It'll figure out if it's moving, how to intercept it. So when I do events up in the mountains, where we don't have any cell coverage, this is how I keep track of where people are by looking at this. And because the eye gates or not, the digipeaters out in the plains are hitting, and I'm picking those up so I can see where people are all around, which is really handy. And so I can actually text message those other stations if I need to. And I've done that before when we had some things going on, when we didn't have very good radio coverage. But we still, for some reason, we still have good, we didn't have good voice communications, but we had good APRS communications. So think about that. So here's an example. I have an Android tablet with an HT, and you can get a cable from like a bow phone. And there's some other radios you can get it that hooks right into it. Either what is it? What's the iFruit name? What do they call theirs? The tablet, the Apple tablet. What is it?
iPad?
iPad, that's it. So they have one for the iPad, and they have one for the Android, and it could be a phone too instead of a tablet that could be doing this. I call it the iFruit. That was what was that in? That was in Dilbert a long time ago. All right, SSID. So the one thing about an APRS is you have an SSID, you have a station identity ID. And these are some of the ones that are used by, these are the recommended ones. So if I'm a fixed station, I might have to set up a base someplace, it's a -0. If I'm mobile, it's a 1 through 4. And also, if you're running more than one station at the same time, you can have 2 different SSIDs going, maybe have 2 things going on. D-Star, iPhone, Android use -5, HTs are -7. If you have a boat or an RV, it's -8, -9 for primary mobile messaging capability, which is what I am. So my setup in my car is a -9, and a -10 is an iGate and a home station, basically. So if you're a digipeater, you might use a -0. So these are the symbols I was talking about. You can't see them real well, but they have all kinds of symbols, and there's several different tables of them. And they don't send bitmaps. When you look on a map, an APRS map, those are not sent as bitmaps. Those are sent as a character reference. So it'll tell what table it belongs to and the symbol number in the table. And so what'll happen is the software will pick that up and then put that symbol on the map, whether you're using your own software or if it's on APRS.fi, which we'll get to. So it's pretty nifty. They have all kinds of symbols. They have airplane symbols. They have, there's a guy walking a dog. He runs around. He's out in Aurora. He's walking his dog, and that's the symbol that shows up on the screen. I have a minivan for my symbol because that's what I drive. If you have a pickup truck, or a regular delivery van, some people have delivery vans, and that's the symbol they're doing. So all kinds of symbols. You just go through and you look at them. And the radios support these symbols, so you can actually pick them out in the radio. Yes.
Do they support Unicode, or is this just a unique set of emojis?
It's a table number. Let's see if we look on here. Yeah, it's got 2 different choices on table there. There's actually a lot of different tables. And then it's just an ASCII code that indicates which symbol would pick off the table.
Okay, so it's not the standard emojis that are part of Unicode.
Yeah, there are some emojis in there. Some of them have something similar to that. I mean, they have hospitals, they have police stations, they have all kinds of stuff. They have the big G that looks like something from you know. So that's supposed to be an eye gate. So the place to go to see all this activity is APRS.fi. You can get you can register to get an account on it. Doesn't cost anything. .fi, for people who don't know, that's Finland. So that's the main servers are in Finland. Their servers are all over the place. But this is where you go to the main map. And this is Colorado. And you can see Rocky Mountain Arsenal there. At one time, the most deadly place on the planet at Basin F, where there was VX and nerve gas, that kind of thing. Anyway, so you can see people here with these lines, those are moving and they're showing their path for the last hour. And you can change that in the parameters for what you're watching. So you can see where people are going from and to. It also shows a lot of weather stations. There's a way to filter those out, but I've never figured out. If someone knows how to do that, please see me later. I'd like to know how to filter those weather stations out. Those are the ones with the W's. You can also look at packets there. Mark and I were looking at some of the packets he was going to do, and I was looking at them to see what kind of data he needed to add to that. So one of the things you can do in there is you can do a search. You can put in a call sign and search to see where they are. So there's my call sign and SSID. I put it in, and it shows right here. It pops up. It says here I am. It says my elevation was 5,833 feet. I was driving 11 miles per hour, and here's the date and time and locations on the map. It also shows where I came from. So someplace looks like I came from downtown, and I drove south and then came around and I went to this location, which is my house. And I came from downtown. I can't remember. I have to look at the date. Oh, I was working downtown maybe. Oh no, I think I was going to an event. I'd already been laid off by that time. Anyway, what's really nice is when I go into work in the morning and I'm sitting there doing my log, keeping track of my work at mines, and I said, oh, when the hell did I get to work? And I'll go and I'll look it up. I go, oh, I got here at 9 o'clock. So I put down 0900 in my logbook. Comes in handy. As long as you remember to turn the radio on. All right, so let's talk about messaging. That's a part of APRS is messaging. It's very important. So I could send an RF text to somebody. Now, you asked about if you just had your system sitting there, you weren't hooked up to a radio. So in theory, if you were hooked up and had a passcode to get into the server, you could send a message to somebody that's on APRS, because it will go out your computer to the server, and the server will find the nearest radio and send it to them. Just like a cell tower. It would find the nearest radio to them. Yeah. It's on APRS. So that would work. That would work. So anyway, on this, so my friend K0GRC, Mike Sullivan, we both worked at a number of places for a long time. He's a geophysicist as well, and he's an extra. So I could send him. So what you do is you there's a way in the software, depending on your APRS software you're using, whether it's on the radio or on some other software like Zaster, is you can put in who you want to send a message to, you can put the call sign, and then after you do that, you put in your message and you hit send. And it'll go out of the radio, or if you're on your computer, we go through the internet through the computer, it'll go out on the radio, and eventually an iGate will catch it, send it to the server, and the server will say, let's see, here's the closest guy to him. We'll have him send out the message. So Digipeater would send it out, and his radio would get it, and he would see the message. And all that would take less than a second. It might be half a second. It's that quick.
What happens if his radio isn't turned on? Would it hold it?
If his radio wasn't turned on, it would hold it. I have had that where it holds it for 24 to 48 hours. So if he turned his APRS radio on, eventually that message you'll see, when he turns it on, it'll send a beacon, the system said, oh, got a message for him, boom, and it'll send it to him. Should get it within a few seconds after he turns it on. So also you can go online to findyou.com and they have a CGI interface where you can actually text somebody as well. So you can do that as well. And that works, done that. Email, you can send email to somebody. Especially if you know their call sign and they are a member of ARRL, because then you can send it to their email address, ARRL, if you know it too. Of course, everybody with a cell phone now, you can send, if you know their email, it'll go to their cell phone if they have it on and they have cell coverage. So you send it either email or email to, and then you put who you're sending it to, like in this case, K0LEI@ARRL.net. And then right after that, you do a space in the message line and you start typing your message. So when you put that to email or email to, the system interprets that knowing that it's an email. And then it looks for a valid email address immediately following that at the beginning of the text of the message. And you can also send a message to a cell phone. This is one way. This is a simple way. So you do email again, but now this is for Verizon. So I got my phone number there. It's at vtext.com. That's what you use for Verizon for texting over a cell phone. And then immediately after that, a space, and then you start your message. You cannot reply directly. Yes.
How many characters?
Depends on the system you're using. I think my Kenwood can do 255 characters. You might be able to do more. I think it might be limited. You might have to do more than one. Just like you might text, when you text, it'll run out on your phone. I think it might be limited to 255 characters, but I'm not sure. That's a good question. So, but then you just do multiple pieces that send out. Like I said, you cannot reply directly on this. Now, SMS to a cell phone. And this one used to work all the time, and it's now not working as much. And I'll explain why when we go through this. It does work in some areas. So the website to go to is smsgte.org to get more information. And normally you would do to, in the to field would be SMSGTE. And then you would put at, and then the phone number, and then you start your message. It used to work all the time. You had interactive texting. What was really nice was I could be up in the mountains. I didn't have cell coverage. But I did have my APRS working, and I could send a message to my wife and she could message back. Now she's a ham as well, but she was on her phone, which is the fastest way to get contact with her. And we could message back and forth what's going on. Unfortunately, this is down. And here's the reason. 10 minutes, thank you. Unfortunately, the reason it's down is because somebody figured out the phone numbers. And what happens when you send this is you get the person at the other end gets a phone number and they text back to that phone number. Somebody that runs spam found these phone numbers and started spamming them. And with the new spam regulations, mainly coming out of Canada, the person had to shut this down because of that. Now, they haven't brought it back up yet. There's a guy in Philippines has it running, and he did some kind of scripting that he wrote, and he's a telecom guy, and he figured out how to do it. He's also a ham. But I don't think it's working everywhere here, because if it is working, it's somebody privately that's doing it. What we need to do is get all our clubs together and get support of the ARRL and figure out a way to get this up and running again. And the reason is that when you're in an area where there's no cell coverage, but you have to get a message to somebody that might have it, this is a great way for emergencies and things. So it's really important. I had some suggestions for them, but I haven't heard back from them. They do have, we'll talk about resources. I want to get through this now. So the way the text APRS goes cell, you can see there's handheld radio, HT, goes out to a tower, radio tower. The radio tower it could be just an antenna. It's an iGate most likely, and it goes through and eventually gets to the cell phone through the cloud. Quickly, here's what an APRS droid interface looks like. So that's like 3 different screens of the same phone. So you only see one at a time. And you can do interactive texting with APRS droid. So if you have APRS droid and somebody else has APRS, you guys can talk back and forth, or 2 droids can talk to each other the same thing using that APRS network. And also, WinLink supports APRS. It's called APRS Link. They only support Kenwood radios. And if you have one and you want to know about it, you can go to winlink.org and go to APRS Link for more information. Finally, technical resources, APRS.org is the mothership for that. Ham radio outlet, if you go there, find someone who knows something about APRS that can talk to you about it. Tapper has information about it. DX Zone has some stuff about it. Software resources, winaprs.com, APRS-is.net. Then the APRS isce.wiki.com, which I mentioned earlier. Pinpoint APRS for that. Zaster.org for Zaster. And SourceForge. You can actually look for, that's Yak, yet another APRS client. And you can download it. I think they have executables that are there. If not, you can, if you're good at compiling, you can compile. There's a lot of YouTube resources. There's just 2 here you can watch. Just, go search on YouTube for APRS and find all kinds of stuff. Google groups. There's an APRS Google group. There's one for APRS ISCE. There's one with Kenwood radios for APRS. And there's now Yaesu radio groups that talk about APRS as well. So it looks like FTM 300 does support it because I put it on there. I know because I went to these sites checking them out. Real-time maps. I already talked about APRS.fi. That's the mother of the maps. And then findyou.com works as well. Finally, on the last slide. You didn't even have to give me the 5-minute mark. So APRS is a useful real-time communication protocol, reasonable cost to implement, can send messages and email. And it's a functioning part of emergency operation. Didn't talk much, I just a little bit hinted about it, like events and things with situational awareness. All right, more questions? Hit me. Yes.
I don't understand how you send messages from the mobile station, for example. How do you enter the text, the H and the
It's either going to be in the radio's interface or it's going to be software, one of the 2. There's a place there to send a message to a station.
when you say on the radios, is it a virtual keyboard?
It's more like a telephone keyboard.
Okay, so not.
It depends. Yeah, some of the newer radios can support a keyboard. So you would have a keyboard, extra keyboard. Yes.
Is it like memory storage to store common?
Yes, there is. There is a common response on some radios. Like the Kenwood has common responses. Like I have in there that when someone sends me a message, instead of me having to manually, because I'm driving, I have it automatically send that I received the message. And I see the message on there for a second or two. And if it's really important, I'll pull over and then answer back. Yes.
And then on your iPhone, on the APRS apps, there's a whole ton of them on.
Oh, good. So on the iPhone. Okay, good. So there you go. Let's confirm that. It's out there. If it works, it'll work on the iFruit just like it does on the iPhone. Anything else?
Just a comment about APRS net on Thursdays. There's a APRS Thursday, and there's a worldwide net where people check in. There's a lot of traffic on there, and you can see everyone's cost. When they're checking this net on Thursdays, so they do that on Instagram and Facebook groups.
So how are they doing that? How are they doing this check-in? It's just
We got and ANS server or something like that.
Oh, okay, okay.
Message the ANS server group and say, checking in on frequency out there, hello everyone, and you subscribe to the
And-
replies, and you'll get them all. If you don't want to subscribe to them, you can cancel it out. So, send a message.
I want to talk to you later more about. What's that? They said that there's an APRS net on Thursday nights, and they're able to check in and all that kind of stuff.
Is it on
So,
a local 2-meter channel or is it on?
yeah, is it on 144.390 or is it on the map?
It's just a worldwide APRS net. So I think the two are running it are in the Midwest somewhere, but it's on Facebook and Instagram, and it's all hands are.
Is it audio or written?
No, it's just like sending an APRS message.
Yeah.
Oh,
just send-
over
you're
the
sending
internet.
APRS message.
Yeah,
Oh,
so it's
okay, got it.
messaging.
Sorry.
It's messaging,
Yeah,
yeah.
so-
Okay.
You go to their website, and as the calls come in, they all show up on the page, so you can see if they're
Oh, cool.
being heard
Okay.
or not. And you can bring your radio on and see, just what's going on .390, because sometimes you're driving around, you don't hear anything on 390, and then
Right.
Thursdays you kind of always do, because there's a lot of people.
Okay. So I might want to bring my radio up on 144.390 at home.
Just think to see what you hear.
Yeah.
I had about,
Okay.
Mobile Link, TNC.
Oh, yeah, mobile link. I forgot to show the mobile link. I picked one up from an estate, really good buy. It's still new in the box. And I haven't played with it yet, but that works really well in handhelds. Jason KA4MCK, I think.
Yep.
MCK. He does YouTubes on mobile link and APRS and stuff like that.
So you can use APRS Droid to hook up to the Mobile Link.
Yes, yes, yep, yes, APRS Droid, yes. And that would work with the Android tablet as well. There's no other question. I think we're done.
Thank you, Larry.
Thank you.